The next section of this booklet looks at CT scanning and X-rays. First year we did this, we spent weeks and weeks and weeks looking at how CT scans work, how they operate, how we generate them and everything else. And the question that they asked in the paper was, what does CT stand for? So do learn off the basics. So it stands for computed tomography. Now, CT scans are based on X-rays. So the first thing we're going to look at is how X-rays are generated, and then we'll look at how CT scans work. So X-rays, as you know, are just high frequency electromagnetic waves, but now in this booklet we should be thinking about that as being high frequency photons, and by that we mean photons that contain a lot of energy. Because they contain so much energy, it makes them quite hard to produce. So how we do it is by this, okay? We have a little cathode, which is just where we heat up a little filament like in a bulb, and it heats up so much that the electrons in that wire gain enough energy so they can leave the atoms. So we have all these little electrons floating about here, and what then happens is we make our cathode is negatively charged and our anode down here is positively charged, and what it does is it creates an electric field. It essentially attracts the electrons. You use a big enough voltage, they get attracted, have a large acceleration, and they travel at very, very high speeds, and then just hit in to our tungsten anode here. And what we want to happen is that the kinetic energy in those electrons then gets transferred into X-rays. Okay. For that to happen, we need a vacuum in that chamber so they don't hit into air particles and get slowed down on the way. However, it's a very inefficient process, this. So maybe about 99% of the electrons that hit into the tungsten atom just generate heat energy rather than X-rays. For that reason, this little anode down here, you see there's a little motor. It tends to turn around so that the point that the electrons are hitting into down here changes, otherwise it would heat it up and melt the metal. So we have to spin it around to allow other parts of the tungsten anode to cool down. This will then generate our X-rays, which we then pass through the human body. Unlike light, X-rays can pass through the human body, but unlike really strong high frequency gamma rays, some of them will pass through, some of them won't. The more dense the tissue, the less of the X-rays can pass through. So we then take kind of a photograph of those X-rays on the other side, and where those X-rays have been attenuated, we can then see the more dense structures like bones in the human body.